Hi friends, welcome back. This is Jajish Thomas from omnisecure.com. Today we will discuss about binary, decimal, hexadecimal number systems and their conversions. And the focus of this lesson is mainly on networking related fields. And keep in mind, this is not for higher engineering studies or mathematical studies. The focus of this video lesson is only to teach the networking professionals or networking students how to use this binary, decimal and hexadecimal number systems, and how to use this in addressing and subnetting related uses. Okay, we already know, we already heard about these terms, binary, decimal and hexadecimal number systems, and people, when initially when they hear about these names, okay, it was a little bit confusing. Even for me also, it was initially it was confusing. But the concept is very easy, very simple. You just need to understand what are these number systems are. We need to use this mainly in our addressing IP version 4 and IP version 6 addresses and subnetting. So the decimal conversion will be binary to decimal conversion, and decimal to binary conversion is useful mainly in IP version 4. IP version 4 addresses. IP version 4 addresses are really binary numbers represented in decimals. You know that. IP version 6 addresses are again binary numbers represented in hexadecimals, right? So IP version 4 addresses are 32-bit in length, and IPv6 addresses are 128 bit length. Okay, so if you are learning IP version 4 addressing, you need to know about the conversion from binary to decimal and back from decimal to binary. And if you are studying about IP version 6 addresses, you need to know about the binary conversion from binary to hexadecimal and back from hexadecimal to binary. So that is very much required for your career in networking. Okay, now we have an entire lesson dedicated in omnisecure.com for binary, decimal and hexadecimal conversion. Please go there, click on TCP IP, and here we have that lesson, binary, decimal and hexadecimal numbers and conversions. Okay, so binary system is a number system which is based on 2. Okay, 2 means we have only 2 characters, 0 and 1. Using 0 and 1, we have to represent the entire numbers in binary number system. In decimal number system, we have 10 characters, 0 to 9, 10 characters, and we have to define represent the entire numbers in numbers using this 10 characters, 0 to 9. In hexadecimal number system, we have 16 characters, 0 to 15, that is totally 16 characters, and we can define the entire number system, or we can represent the entire number system using these 16 characters. Everything is same but represented in different ways. That's it. Okay, now we will start with decimal number system. So in day-to-day life, all the humans we use a decimal number system, because for us it is easy to work with decimal number system, because from the beginning itself we started learning based on the decimal number system, that is based on 10. A number system, decimal number system is a number system which is based on 10. So from the beginning itself we learned our mathematics based on decimal number system which is based on 10. So what is it actually? So I will try to explain this number system based upon my favorite fruit, that is mango. Okay, now here in this picture, how many mangoes you can see? 1 2 3 4 5 6 7 mangoes. All right, 8 mangoes, 9 mangoes, right? So in a box, okay, you there are 10 mangoes. How will you count it? We'll start from 0 0 1 2 3 4 5 6 7 8 sorry, 1 2 3 4 5 6 7 8 9, and we have one more mango, 10. So how will you write this one? We'll start from so if I one if you have one mango, if you count from the beginning, we'll say okay, one, this is the first, uh, sorry, if nothing is there, it is 0. Okay, we don't have, we have 10 mangoes there, so we will start counting from 1. So this is 1, 2, this is the second one, 3, third one, 4, 5, 6, 7, 8, 9. Okay, now our numbers are over. If you talk about the characters, up to 9 we have used up to 9, and we don't have any characters left. So what is the next number? 10. How will you represent the 10 here? We'll use 1 and then put a 0. That is the number 10. Alright, then again it's a repetition. 1 plus 1, 11, 1 plus 2, 12, 1 plus 3, 13, 14, 15, 16, 17, 18, 19. After 19, what we will do? We'll put a 2 and put a 0 there. This number system is what we are saying it's based on 10, because it's a like now keep on repeating by adding the next number in the position of 10, and we keep on adding this number. When it reaches the 10, again we will repeat from 30, 31, 32, 40, 30, 34, 35 up to 39, and then it will come again. We'll put 4 here. After 30 is over, after 31, 32, 33, 39, we will write it as 40. That is keep on repeating from every 10. It's a repetition of 10, 10, 10, 10. Okay, this concept is clear, right? So decimal number system is a number system which is based on 10. Keep on repeating it. If once we reach 9, we don't have a character to represent 10. So what we will do, we'll keep a 1 here and use 0 here to represent 10, the number 10 there. This is what a binary number system is. So we'll talk about hexadecimal number systems. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we already learned that this is a number system based on 16. Hexadecimal numbers are a number system based on 16. Okay. Now how will you start from counting on hexadecimal numbers? Same as before. What we'll do? So this is the first mango, second mango, third mango, fourth, fifth, sixth, 7, 8, 9, 10, 11. So these normal decimal number, after 9 we use 10 to represent the next number and 11 to represent the 10 number, but in hexadecimal it is not like that. After 9, 10 is represented by using A. 10 is represented by using A. 11 is represented by using B. 12 is represented by C. 10, 11, 12. 13 by D. 14 by E. And 15 by F. Correct? So we have F in hexadecimals, which represent the number 15 in decimal. Okay. In decimal we don't have this A, B, C, D, E, F. In decimal we never use A, B, C, D, E, F in decimals. But in hexadecimals we use A, B, C, D, E, F to represent numbers 10, 11, 12, 13, 14 and 15. Okay. Now 15 is over. How will you represent 16? A question. Remember, in decimals, after 9 what we will do? We will use 10. 10, how will you represent 10? 1 plus the least one, 0. Similarly, in hexadecimals, 16, the number 16 is represented by 10. You got the concept? Again, it is starting from 10, 11, 12, 13, 14. You remember in decimal, the same concept here. You are getting it? Now, this is 16. Okay. So what about 17? 17 is represented by the hexadecimal number 11. Do you want to check it? Again, open the calculator. Go to programmer mode. Okay, decimal. Which number? 16. If you convert into hexadecimal, you can see it is 10. Decimal, the number 17. If you convert into hexadecimal, it is 11. So it goes like that. So 11 is 17. 12 is 18. 13 is 19. 14 is 20. 15 is 21. It goes like that. Okay, you understood the concept, right? So if you want to again check it, go to decimal and 21 convert to hexadecimal. You can see it is 15. So I will write the corresponding numbers also, decimal numbers also here. So the number 1, these numbers which I wrote over the mangoes are hexadecimal numbers. The corresponding decimals I will write here. 1 is 1 only, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7, 8 is also same in decimal, 8, 9, and A. In decimals we don't use A, we will use what? Use 10 here. B is 11, C is 12, D is 13, E is 14, F is 15, 10 in decimals it is 16, 11, 17, 12, 18, 19, 20, 21. It go like that up to next repetition come. What is the next repetition? Sorry, I need to expand that. Okay, 15 is 21. 16 hexadecimal. uh, in decimal it is 22. Okay, if you have doubt, again always you use the calculator to find the correct value. Sorry. 16 in hexadecimals. So select hexadecimal first, use 16 here, click decimal, the decimal value is 22. 17 in hexadecimal, 23 in decimal. 18 in hexadecimal, 24. 19, 25. After 19, what is the next number? After 9, we don't have we have there is we cannot use 0 here as the next number, because this is a number system based on hexadecimal. So 1a, that is the next number, you remember, 1a. So 1a is 26 here. You check it, always check it using a calculator. Go to hexadecimal, 1a, convert it into decimal, 26, corresponding number is 26. Decimal number, I meant decimal number, sorry. 1b, 27. Okay, we can check that also. 1b, decimal 27. Decimal value is 27 for that. 1c in decimals 28. 1d in hexadecimal, in decimal it is 29. 1e in decimals, it is after 1e it is 30, correct. So in decimals we can use after 3, we don't have a here, so 9 we use the next number 30. 2 is 29 is over, the next number we'll use 3 here, and that again start repeated from 0 to 9. 1e is 30, 1f is 31. Take your calculator, again find it out. Hexadecimal, 1f in hexadecimal, 31. That's it. We don't have any characters in hexadecimal after f. So what is the next solution? How will you number 32? How will you use the number 32? What is the equivalent of number 32 in hexadecimal? This f is this a b c d e f, f up to f we have used. So again we will start from 2 and 0. The number 20 in hexadecimals is the equivalent value of the number 20 in hexadecimals is 32 in decimals. I got your I think your concepts are getting clear. 21 in hexadecimals is 33. Okay, now there is a confusion, you have a confusion. Okay, this number is decimal or hexadecimal, this number is decimal or hexadecimal. Okay, we started from writing on top on the mango the hexadecimal, so now here you can understand. But some many times you may see a number something like this, 2001. This is decimal or hexadecimal? Always a confusion. It can be a decimal or it can be hexadecimal, because in both decimals and hexadecimal we use these characters. These 200 characters are already there in decimals and hexadecimals. So to identify hexadecimals, the scientists and the engineers use 0x before hexadecimal. Okay, if you see a number 0x before a number, so this identifies this is a hexadecimal number. Okay, so 2001, before that if there is a 0x, you need to understand this is not a decimal number, this is a hexadecimal number. Okay, this concept is clear, right? So go to omnisecure.com sorry, omnisecure.com website, and here we have a table at the bottom. We have the decimal, binary and hexadecimal numbers table. You can see that 0x is I have written the 0 is also here. Go there and just understand the concept. Everything is same, but represented in three different ways. Okay. Similarly, binary number also another way to represent it, but in binary number we have only two characters, right? We have only 0 and 1, right? We have to represent the entire number system by using these two characters, 0 and 1. Okay, so here we use something known as a power. Now keep in mind that I am teaching this for networking related binary and hexadecimal number system. It's same actually for but here we are more concerned about an 8-bit binary number. So what is an 8-bit binary number? Because IP version 4 addresses are 32-bit binary numbers divided into four part. So each part will contain 8 bits. So first of all, I will write that 32-bit number system numbers 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. So this is a 32-bit number, right? 32 bit. So each part is a bit. This is bit, single bit, this is another bit. 1 2 3 4 5 6 7 8. So 32-bit IP version 4 address is a 32-bit binary number divided into 4 part. So each part will get 8 bits. 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 again 1 2 3 4 5 6 7 8. So here in this class, in this video lesson, we are more concerned about an 8-bit binary number, because here the conversion in networking field from binary to decimal happens for 8-bit numbers most of the time. Okay, so you need to come here and learn this table by heart for the powers of 2 for 8 bits. For 8 bits, I'm just copying this one and pasting on the bottom. These 8 bits, the rightmost bit, this is known as the least significant bit, and the leftmost bit, it is known as the most significant bit. Least significant, most significant. Okay. Now in this power table, the rightmost bit is 0th power of 2. Any number raised to 0 is 1. Whether it is 2, 3, 4, 5, whatever it is, any number to the power raised to 0 is 1. The next is 2 to the power of 1, that is 2. 2 to the power of 2, that is 4. 2 to the power of 3, 8. 2 to the power of 4, 16. 2 to the power of 5, 32. 2 to the power of 6, 64. And 2 to the power of 7, 128. Okay. Now take this binary number. Here all the bits are 1. That means if you convert 2 to the power of 0, the decimal equivalent is also given here. 2 to the power of 0 is 1, right? So you have to put here 1. This is 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, Okay, here in this 8-bit binary number, in this example, we kept all the 8 bits as 1. That means the corresponding part in the power table, you remember the power table 0, 1, 4, 8, 16, 32, 64 and 128. The corresponding powers to the power of 0 is 1, to the power of 1 is 2. For example, any bit is 0, any bit was 0, we will keep the corresponding bit here also, corresponding part, this is also 0 here. Now here it is 1, so we keep the corresponding number here as 1. So we have to sum up all these numbers. So if you add all these numbers, we will get 255. So the maximum possible value, all the bits kept for an 8-bit number is 255. The maximum possible, the decimal equivalent, the maximum possible decimal value which you can make from a 8-bit binary number is 255. So there is an equation to find out that one. So if you have a 8-bit number, 2 to the power of 8 minus 1, that will give you the maximum possible value which can create from a 8-bit number, and 2 is the base, 2 is the base, 8 is the number of bits, minus 1, you will get 256 minus 1, that is 255. So what will be the maximum possible value we can create from a 10-bit binary number? 2 to the power of 10 minus 1, correct? That is 2 to the power of 10 is 1024, right? 2 to the power of 2 to the power of 10 is 1024. Minus 1, 10, 23. How will you find it out? You go to programmer mode and go to binary, write all bits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a 10-bit number, and this is the maximum possible value which we can get from a 10-bit number because all the bits are 1, correct? If you keep it into decimal, you can see 1023. So that is a maximum possible value which we can create from a 10-bit number. Now we are not much bothered about the 10-bit binary number, because here in IP version 4 we are concerned with the 8-bit binary numbers, because all the 1 octet in an IP version 4 is a binary number which is made from 8 bits. Okay, this concept is clear, right? So there are some worked out examples here for from binary to decimal and from decimal to binary. For example, take this, convert 192 into decimals, convert 192 in decimal to its binary equivalent, 192 in decimals. Okay, so if you want to get 192, how will you add up the powers of 0? 128 plus 64 is 192, correct? 128 plus 64 equal to 192. So we have to keep this 8th bit, this is 1, 2, 3, 4, 5, 6, 7, 8th bit and 7th bit as 1, and remaining all the bits are 0. So this is 128 plus 64, we will get 192. Similarly, take this example, convert 172 in decimals in decimals to its binary equivalent. To get 172, which bits we have to keep on and which bits we have to keep off? 128 plus 32 plus 8 plus 4 will give you 172, correct? If you have any doubt, you can check it. 128 plus 32 plus 128 plus 32 plus 8 plus 4 is 172. So we have to keep 128th position, the bit of the 128th position, that is 8th bit as 1, 6th bit as 1, and 4th bit as 1, and 3rd bit as 1. All the remaining bits 0. We will get 172. So if you have a doubt, you can check it in calculator also. So how will you write this binary number? Go to binary, select binary here. 1, this one, 0, this 0, again 1, this one, 0, 1, 1, and remaining 2 zeros. 2 0. 1 0 1 0 1 1 0 0. Okay, 1 0 1 0 1 1 0 0. Correct. Decimal 172. So practice these lessons. You can clearly understand the concept of converting from binary to decimal, mainly for an 8-bit number, because as I told before, we are here in this networking field. We are more bothered about the 8-bit binary numbers, because in IP version for addressing and subnetting we use conversion from decimal to binary for 8-bit binary numbers. Okay, so our target is to learn the binary to decimal conversion of 8-bit binary number. So this lesson is mainly for that, to learn conversion from binary to decimal for an 8-bit number. So keep in mind that. Okay, this is how you convert. Practice these lessons. There are a lot of lessons I have created, lot of examples I have created here, so you can practice these numbers well and can gain good knowledge in conversions. Now, how will you convert hexadecimal to binary and binary to hexadecimal? Because in IP version 4 address, we have to use hexadecimal numbers. IP version 6 addresses are 128-bit number divided into how many parts? 8 parts. So totally we have 128 bits divided by 8. So each part you will get 16 bits. So it looks similar to this one. 1 2 3 4 5 6 7 8. First part. So this is how many bits? 8 bits. 8 plus 8, 16. Alright. 16 bits. Again 16 bits. So 2 part. Again 16 bit. 3 part. Again 16 bit. 4th part. Again 16 bit. 5th part. Again 16 bit. 6th part. Again 16 bit. 7th part. And again 16 bit. 8th part. See how huge it is. Okay, you will just make the font little bit smaller so that we can try to make it everything in a single line. Edit, format, font, make it 12. Too small. Okay, 128 bits. So this is an example for a IP version 6 number in its binary natural format, basic, what to say, it's as it's handled by the computers. So 128-bit number divided into 8 parts. So each part is 16 bits. Clear? So we will take a single part. Okay, so we'll make a little font little bit bigger so that you can easily see that. 16 bits. So in hexadecimals, they call something called as a nibble. Okay, 4 bits constitute 4 bits binary number, they call it as a nibble. So here how many nibbles are here? 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay, 4 nibbles make one part of an IP version 6 address. Now this is a 4-bit number. Alright, it's 4-bit binary number. This is a 4-bit binary number. And how many combinations of numbers you can make it from a 4-bit binary number? 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1 1 0 0 0 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1, right? This much combinations of numbers you can make from a 4-bit binary number. So what is this value? This is 0 only, or bit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is correct. I am just keeping it from my mind. I will check it again once again later. 11, 12, 13, 14, 15. Okay, so using a 4-bit binary number, we can make 16 numbers, 0 to 15. We can make totally how many numbers? 16 numbers, correct? What is the maximum possible value? 15. You understand this concept clearly? So by using a 4-bit binary number, we can create 16 numbers, and the maximum possible decimal value which we can create from a 4-bit binary number is 15 when you keep all the bits 1, right? So you remember the table we learned before? 15 in binary 1111, in hexadecimal it is represented as F. So the equivalent of 1111 in hexadecimal is F. Again we have one more F. Again we have one more F. Again we have one more F. For F. Clear? So a binary number equivalent to this, we can represent that number in hexadecimal using F. Want to check it? Copy this, use a calculator, go to binary, paste it here. How many bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Select hexadecimal all F. That's how you convert an hexadecimal, a binary to hexadecimal. Very important. In future, maybe I don't know, after 5 years, there may not be, when the next version of operating system come, who knows, then there may not be an IP version 4. We will be concentrating everything on IP version 6. Every network will be operating in IP version 6. So you have to start learning the concepts now itself. So all the bits 16 bits 1, we can represent that number in hexadecimal using FFFF. Oh, what is the binary equivalent of this one? All bits, 16-bit number, all kept as 1, 6, 5, 5, 3, 5. You have any doubt? Open calculator and take decimal 65535. Correct? So the normally in day-to-day life we use 65535. That number in the binary format or binary representation, we can represent something similar to this, and hexadecimal number we can represent something similar to this. Now why we use this hexadecimal number? Okay, you remember the same number, 16-bit binary number, 128-bit IP version for address. If you were representing that in decimal instead of hexadecimal, that number will look something similar to this: 65535, 65535, 65535, 123, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. Okay, if you represent, say I am talking about 128-bit IP version 6 address. One, 2, 3, 4, 5, 6, 7, 8. This is what that 128-bit IP version 6 address we were talking about. If you represent this one, obviously we cannot handle this much of big number, because who can remember this much of big number? No one can remember that. That is why we have to represent it either in decimal or hexadecimal. If you represent it in decimal, this is the case. So one part, if you convert into decimal, you will get a number similar to this one. Second part, if you convert into decimal, you will get something similar to this one. Third part, to represent like this in decimal format, if you the same number, if you represent in hexadecimals, which one is simpler for humans to handle? This number, or this number? Obviously this hexadecimal. That's the reason behind the geniuses networking gods from IETF. They decided, okay, we will not use this decimal number anymore. We will use hexadecimal to represent IP version 6 addresses. Now I hope the concept you are getting clear. If you have any doubt, again go back to our networking lesson, binary to decimal and hexadecimal, binary, decimal and hexadecimal numbers and conversion lesson. You can reach this lesson by clicking to TCP/IP and clicking into binary, decimal and hexadecimal numbers and conversions. And here all the concepts are explained clearly. Please go there and read and try to practice the examples which I have already given there, and make your own examples and practice yourself so that you can clearly understand these number systems. Thanks a lot for spending your time to watch these videos. I hope you understood the concepts which I tried to explain. I request you to please forward your comments and feedback to following email addresses: admin@omnisecure.com, author@omnisecure.com. If you believe the time you spend here is worth, please give us a like at our Facebook page. facebook.com/omnisecure. This is Jajish Thomas from omnisecure.com. Thanks a lot for watching.